And we're live, I think. Is this working? Probably not. Refresh that. Are we live? Green Square says I am. Um, okay, awesome. So, welcome whoever is watching. Today I'm gonna take a break from writing in Rust because I want a win. Yesterday I only finished part 1 and I didn't have enough energies to finish part 2 of day 5. Today we're gonna do day 6 in Python, which means that we are gonna ditch Rust Rover for now, and we're gonna use PyCharm, and we're gonna solve this in another language, which I'm much more familiar with. And Trust Project in no, that's not okay. Trust Project. And let's just initialize our own virtual environment, and then we'll go on and actually read the thing. Oh, Rust in peace. Oh, I mean, I will go back to Rust on the weekend when I have a little bit more energies to actually like learn more Rust. But right now I'm also tired. I'm like between busy days at work, and I do need like some sanity in my life. So yeah. Right, sync, and we're gonna do this very quickly. Python 3.8, fuck, get out of it, get out of here. No, Python 3.11, we're gonna go for something fast. We can also go for the 3.12 version, but whatever. Yeah, and let's just write Python now, and yeah, we've got our own virtual environment, and everything is working. Awesome. Let's initialize the thing. AI assistant. Get out of here with all of this AI assistant crap. I don't want any of this. Let's remove a lot of the things that just display project colors. Show tool window. I think that's the one. Yeah. Okay. Clean. Clean. I want clean stuff. And let's add our local interpreter. So existing virtual environment. Okay. And we've got our interpreter set up. Ran, I really appreciate you coming here every day. Like it does not go unnoticed. Um, sure. Let's actually dive into making this. So let's go for add event of code, day 6, and wait for it. The ferry quickly brings us across the island. After asking around, we discovered that there is indeed a normally where there is indeed a normally large pile of sand somewhere near here, but you don't see it you don't see anything. Lots of water, blah 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 blah. Okay, that's a lot of wording. I want to actually like go for the puzzle. I was trying to figure out what to do next. You notice a poster wall on a wall near the ferry dock. Boat race. Open to the public. Grand prize is an all expenses paid trip to Desert Island. Okay, probably where the sand comes from. Yeah. Um, Best of all, the boat races are starting in just a few minutes. Managed to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can. As you win, if your boat goes the farthest, and you win if you goes the far, your boat goes the farthest. Um, as a part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race and also the best distance ever recorded on that race. To guarantee that you win the grand prize, you need to make sure that you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button is was held longer, but the time spent holding the button counts against the total race time. You can hold the button and start the race, and the boat doesn't move until the button is released. For example, time something, distance something. So let's look at that. We've got time 7, distance 9, time 15, distance 40, time 13. Okay, something. This document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. The second race lasts 15 milliseconds. The record distance is 40 millimeters. The third race is, yeah, the same thing. Your toy boat has a starting speed of 0 millimeters per second for the whole, for each whole millisecond that you spend at the beginning of the race holding it down. The boat speed increases by 1 millimeter per second. Okay, so this is just quadratic acceleration, constant rate. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all. That is, hold it for 0 milliseconds and start at the start of the race. The boat won't move. It will have traveled 0 millimeters. Hold the button for 1 millisecond and start the race, and then, yeah, the boat will travel 1 millimeter per second for 6 milliseconds, and that's a total distance of 6 millimeters traveled. Then we've got 2 milliseconds. Okay, basically, we know how parabolas work. So this is just the shape of a parabola. Okay, and we can literally just find the maximum. So this is like polynomial optimization. That's very nice. Since the current record in this race is 9 millimeters, there are currently 4 different ways you could win. You could hold the button for 2, 3, 4, 5 milliseconds at the start of the race. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds and beat the record, for a total of 8 different ways to win. In the third race, was there a third race? Yeah, okay. Third race, there are probably way more options, right? Or not? At least, okay, so we've got 9 ways to win. Okay, that's very nice. So we've got like the range, basically. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, you multiply these values together, so you get 288. Determine the number of ways you could beat the record for each race. What would you get if you multiply these numbers together? Okay, so let's dive into that. We've got our day 6. Let's just do that and like I don't know, our Python land, and let's have day 6. And we would first need our input. So that's going to be, yeah, our input is going to be open, well, input day 6 txt, and let's just, yeah, read it in. I mean, this is already like way better than Rust. To get like just a string working, we would have we needed to work so much. And let's actually figure out how would we do this. So we've got, by the way, the puzzle input is probably like a very long 2 lines of things. That's it. But we do need to do like the optimization. We could like literally brute force everything. We don't even need to do fancy stuff. So yeah, fuck that. Let's just brute force everything. So we've got 2 things. Let's just so we've got our input. Oh, let's call that actually just text, because, well, input is a reserved word in Python. So we've got that. We can read that in, and we do need to split it in order to get 2 lines. And we can literally just do the thing where we, let's go with max split 1. Oh my God, this is so much nicer. Okay, so we've got time, distance, and the thing. So let's literally have our, you know what? That's our text. We don't even need to do anything fancy. Ho ho ho. Okay. Um, yeah, so let's split okay, so let's strip that out of like the extra things. And then we can split it into 2 lines. Let's max split at 1, and then we've got, well, not text, but we've got time, comma, distance. And we can literally just run that and it will run. Yeah, okay, so we're not crashing. And just to make to assert that there are no new lines in the thing, can we assert that? Do we need to assert that? Actually, this is a better assertion. Okay, so we've got basically yeah, okay, we've got that. And we could transpose that into like races. So races are going to be the zip of these things. And then we can drop everything from index 1, yeah. So these are our races, and it says zip object is not superscriptable because we need to list it out in order to consume everything except for the first. So list on that, and let's print our races. Okay, so we've got our races all split up. And just because we are actually already doing a lot of things here, let's actually convert everything into numbers. So we've got this, and we can int okay, and we just need to still index into it. And we have these, they say distance is not a thing. Well, if is oh, I see. So we first need to basically we first need to drop like the first thing. So how would we do that? We can say, okay, so we just drop it before we index things before we index into it, and we do now want like the whole int thing. Okay, so we've got our races, or it says no because time is not a thing. And why is it unhappy now? Oh, 1 through, not through to 1. Okay, so we've got all of our numbers basically at in a vector. And now for each of them, we can do like the actual polynomial calculations, and then literally count them up. So we've got our races. So let's call that total traveled is going to be I mean, we need to like for each one of these, we need to like we need to add basically another dimension and then like do the multiplication. We could do like a lot of this math in NumPy, but I'm gonna try to like avoid that. So we are going to have a list of basically a range of time, and then we need, okay, so our distance is not actually, doesn't really matter for now. So we just have the times basically. So let's just have these like separate things. So times is going to be these, and distances to beat is going to be distance. Okay, so we've got that. So total travel, we basically have a list, and for each one of these, we need to do something. So let's think about that. How would we do this? We can literally iterate over, we've got our total time, so we can say, we can literally do the integral of like the distance traveled. So it's actually not even an integral. It's basically, okay, so let's think about that in like comments. So we've got, if we hold for 3 milliseconds, then we are going to travel hold for 3 milliseconds. Gives us 40 minus 3 milliseconds times 3. So this is our like basic calculation. And then that equals to something, which obviously Copilot will not be able to guess, but we will try to do our best here. So let's just do this now, like without actually like accumulating the thing. So for I in range times 0. Let's just assert that times are like somewhat like same for that. So we should see that traveled, that's going to be time minus not 3. Oh, come on. Such a fucking dumbass sometimes. So we've got, well, our maximum, which is times in the place of I, which not I, but 0, minus I times I. And let's just print that in. So print travel distance, and we should expect this to be like in the shape of a parabola. It says, stir object cannot be interpreted as an integer. Why is that? Because we haven't done the whole casting into int. So map int sequence, then we can list all over that. That way we get back an iterable thing. And we do get a parabola, right? Seems like a parabola with a peak at 400. Okay, so we've got that. So let's actually like do these for every race, basically. So for each so we need to just do that like for each of these. So for race and rain, come on, just for literally the race in, oh, I see. So it's for time race time in times. We are now, oh, we could literally do, we do have like one more, it should be actually, because we could literally do 0 through 40 milliseconds. We should be like literally +1 here, but shouldn't matter for now. Anyhow, and then it should be race time. Minus I times I. And yeah, and that should be like our full all of our distance traveled, and then we can literally count them up against like the record. So we've got our record, which is when we zip our times with our distance to beat. And distance to beat should also be list map and all of that crap. We could do like list comprehensions, but that doesn't really matter. And we just need to like, so yeah, count equals 0. Oh my God, Python is so much nicer for doing like low level algorithmic, not low level, but like low effort algorithmic thinking. So basically count plus equals to distance traveled greater than record. Greater than, not greater equals. And let's print our count. Okay, that was the fastest solve, and it's too low. Shit. Okay, let's go back. Oh, because we should have multiplied these. So for each race, we should have not counted up the map like that, but we should have done count equals 0. And then we should say product equals 1. And then we should have said here at the end of each things, product times count, and then we should do the product. And now we submit that. And we need to wait 29 more seconds. I mean, this is, I mean, I understand why. Well, not this thing, this thing. I understand why they're doing that, but this is annoying. 1 more second left. Shit. Submit. Gold star. Wow, that's nice. This was actually quick. This took less than 22 minutes, like from the start of the stream, including me like dicking around with setting up Python. Okay, let's continue to part 2. So, the race is about to start. You realize the piece of paper on the race times the record distance you got earlier actually has a very bad kerning. Um, okay. Um, the glyph was on the right. Okay, I'm not sure. Oh, I see. So things are like overlapping. Okay. Very bad kerning. There's only one race. Ignore the spaces between the numbers on each line. So the number before is just the thing. That's it. Okay. So let's just merge that then. So we've got same text. Let's just have it here. And I'm not gonna bother. I mean, like we know we can pass that, but you know what else we can do? Literally do this. Um, so let's just have time equals to this thing, distance to beat equals this thing. That's just this in singular right now. Then we literally do the same. I'm like very, very lazy. So let's just do that. We don't need the external for loop now. We just say, well, no product anymore because we're just counting them up. And we say our record is this thing. Our race time is this thing. And this should like probably explode, and that's why like they're doing it. But let's see how much does it actually explode. Okay, so it wasn't that helpful. It just worked. Submit. Okay, that was a short day. Is acceleration 1 millimeter per second squared? Yes, it is. Okay, but yeah, that was like this should have been like way more bigger to actually help us and like do the actual algorithmic polynomial optimization thing. This just ended in seconds. That's kind of disappointing. Okay, this was by far the shortest one. Okay, but I'm very happy because I really didn't have any more patience today, so I think I really got like I caught a break. But basically that means also that yeah, you know what? Let's actually like do the thing where we have the time and distance thing. Let's actually like compute the race time here correctly. So we've got the same thing, and instead of that, part two, uh, merge the numbers. And now let's just do that the same way. So we've got, instead of these times which are already, yeah, we need to basically just do this. We need to take our times and we need to replace, before we do that, we need to split and then we could join and then we could replace, sorry, let's literally do this like that. So we say join on empty string. And then we pass that as an int. And we could also do that here. So we say int, and then let Copilot do its thing, where it copies the thing that I've already done. And that should be working, but it has one more thing to do. And it just runs, and everything's okay. That's very good. Okay, so we're done. Yeah, we're just done. This just this just ended. Um, should we do the polynomial optimization? Nah. You can read it up on Wikipedia and like do a college course on that, like for like a bachelor's of science degree. If you want like to do polynomial optimizations, nothing like very interesting then. So yeah, thank you for joining. This was very quicker than I expected. And I'll see you tomorrow, and hopefully it will be a nicer day, and I will probably have a little bit more like wind in my sails to actually tackle Rust. But this is like I really I needed this win, and I'm happy I got it. Yeah. Good night, and I'll see you tomorrow.